Parallel lines have so much in common. It's so sad they'll never meet. It's time to learn geometry now! Hey everyone, I'm your host Barbie. After years of teaching you about border anomalies and trade export sectors and languages and culture and landscape composition, I realize I've been wasting my life. Seriously, it's time to finally think outside of the quadrilateral parallelogram and get rational at this point and get you in shape for the trajectory this channel is heading in. So without further ado... When it comes to the beginning, the earliest known case we have of documented geometric calculations comes from ancient Egypt, in which the pharaohs would use rudimentary concepts and calculations to construct the pyramids with 4 triangular faces and square bases. Otherwise, many will attribute Greek mathematician Euclid as the father of geometry. Back then, a ton of people would come up to him for wisdom and he was all like, "Yo, check it, any 2 points in space will totally make a straight line. Let's call this an axiom." Oh, but he didn't stop there. Then he was like, if 2 straight lines have equal space between them, they are parallel and will hence never intersect. If one or both of these lines are not at equal angles, they will eventually intersect. Then you can connect them and make a triangle. Oh, and hey, check it, if you take any point on a line segment, you can immediately create a circle by using it as a radius and the other point as the center encircling it. Then we can divide it into 360 degrees. And then all the people were like, why 360? That's such an arbitrary number, isn't it? Oh, and then Euclid was like, nah man, 360 is a perfect number because not only is it the number of the days of our year, with those pesky leftover epigomenal 5 or 6 days, but also it's so wonderfully divisive. You can split 360 into equal groups of 2, 3, 4, 5, 6, 8, 9, 10, 12, 15, 18, and 20. Dang, that is a good number. And from there, Euclid was taken like very seriously, as was the rest of the guys that followed him in the centuries to come. Now, as mentioned in the last segment, it will depend on what exact shape or construct you wish to measure, but basically, you will need points and lines. Today, we will cover triangles, quadrilaterals, and circles. Triangles can be tricky because they can come in 6 different forms based on the sides and angles. In regards to sides, scalene triangles have all different length sides, isosceles have 2 equal sides, equilaterals have all 3 equal sides. Whereas with angles, an acute triangle has all angles less than 90 degrees, a right triangle has a 90-degree angle, and finally, an obtuse triangle which has one angle that is over 90 degrees. Keep in mind you can have triangles with variables from both sides or categories. For example, an isosceles right triangle or scalene obtuse triangle. However, keep in mind all equilateral triangles will be acute. However, not all acute triangles necessarily have to be equilateral. Also, keep in mind isosceles triangles will always have complementary angles, which means the 2 angles opposing the third one will always share the same value. Quadrilaterals are any shapes with 4 sides. They are generally classified into 6 different types: squares, rectangles, rhombuses, parallelograms, trapezoids, and irregular quadrilaterals. Squares share equal sides and are all right angles. Rectangles have 2 longer sides but share right angles. The rhombus has equal sides but a set of different yet complementary angles. Parallelogram is like the rectangle version of the rhombus with 2 sides longer, and the trapezoid has 1 parallel and 1 non-parallel set of sides in its makeup. The irregular quadrilaterals do not follow any specific format. However, some will say that the kite should be categorized as a quadrilateral as it has 2 sets of 2 different length sides. Otherwise, you can get an arrowhead or this abomination nobody wants to invite to the party. Circles are the last and final variable we will include. These are strange because they have no points along the edge and technically only one side. In order to measure a circle though, they do maintain a central point for reference as well as an imaginary line that extends from the center to the edges to give the length of the radius and the diameter. This line, although imaginary to the construct of a circle, is crucial because without it, circles wouldn't exist. You need the diameter for pi. What is pi? Basically the ratio of the circumference to the diameter. A rough but slightly inaccurate approximation would be 22/7. Technically, pi is an irrational number because the digits go on forever to the point that pi has no recognizable value. An irrational, technically unrecognizable number for all our curvature calculations. Speaking of which... Geometry is actually in a lot of ways like cooking. Every shape ever made has a recipe. To make the perfect one, you need to know which components get mixed in together. Let's start with triangles. In order to find the area of a triangle, you multiply half times the base times the height. Now, all quadrilaterals are a little different. To find the area of a square, you simply just square the sides. For a rectangle, you do the length times the width. For parallelograms, you do the base times the height. And for a trapezoid, you multiply the height by both bases added together divided by 2. Now, circles are a little stranger. As mentioned before, you need to have pi. pi. So the area of a circle is pi r squared, in which you square the radius. The circumference of a circle, keep in mind, is 2 pi r. And that's about it! In conclusion, this world might be made up of majestic mountains and vibrant cultures and people groups, but in reality, we also live in a world of calculations and numbers that direct our very existence without us even knowing it. Thank you for watching. This episode was brought to you by the government of Bandia Terra.